Hello everyone, this is Shanko and welcome to part 3 of this Java interview series where I talk about important topics and concepts which are frequently asked in Java interviews. So today I'm going to talk about uh, collections and maps in Java. So the first question is, how does hash map work internally? So what is map? Map is basically a data structure that stores records in a key value pair, and the key can be anything. The key can be an integer, the key can be a string, the key can be a boolean, the key can be a custom class that you've written, such as student or employee or whatever. I mean, it can be anything, right? So the fundamental principle of a map is storing data in key value pair so that the searching of objects or searching of elements becomes faster. The searching of elements is really fast in a map compared to storing in other data structures, right? So how does a hash map work internally? So when we are trying to insert an object, or when we are trying to insert a key value pair into a map, what the map first does is, into a hash map, the first step is trying to calculating the hash code for the key. So let's imagine the hash code. So let's imagine we have this we have this array, and let's call these cells as buckets. So this is the 0th bucket, and this is the 0th bucket. This is the first bucket, this is the second bucket, third bucket, and fourth bucket. So we have 5 cells inside our array, and this is going to store our objects, or this is going to represent our map or our hash map, right? Now let's imagine we are trying to insert an element, or we are trying to insert a key value pair into this map, and the key has a hash code of, say, 11, right? And we have how many buckets? We have 1, 2, 3, 4, 5 buckets in our map, right? So what the map will do is, it'll first obviously calculate the hash code for the key, so that is 11. Now it'll do a modulus of the hash code with the number of buckets inside the map, or inside the hash map, right? So we have 5 buckets inside this, and the hash code is 11. So 11 mod 5 is 1, right? So it'll store the element in the first bucket. So this will become our first element, right? LM1, right? Now let's imagine the second element that we're trying to put into the map, or the second key value pair that we're trying to put into the map, has a hash code of 12, right? So again, the same mechanism or the same formula would be applied to this particular key value pair, and when we do a modulus of the hash code with the number of buckets, we'd be getting 2. So if we do 12 mod 5, that would give us 2, right? So it'll go into the second bucket. So let's say we have our second element, in our second bucket, right? Now let's imagine the next element that we're trying to put, or the next key value pair that we're trying to put inside the map, has a hash code of 21. So 21 mod 5 would again give us 1. The remainder, if we divide 21 by 5, we'll be getting the remainder as 1, right? So again, the next element would be placed inside the first bucket. So but it already has an element inside the first bucket. So what it will do is, it'll create a list. and store the third element at the end of the list. So we already have an element inside the first bucket, and we're trying to insert another one inside the first bucket. So it'll create a list, right? So in this way, it'll keep on storing the values, or it'll keep on storing the key value pairs inside the map. And when we are trying to fetch a particular element by using a key, say we are trying to fetch the third element, right? This one, the one that we have just entered into the map, just inserted into the map. So if you're trying to fetch the third element using the key, what it will do is it'll again calculate the hash code for the key. So the hash code is already 21, that is known to us, right? And then again the same technique or same mechanism would be used. So it'll do a 21 mod 5. So if 21 is divided by 5, we get the remainder as 1. So it'll know that we have to look up this element inside the first bucket. So it'll look up the element inside the first bucket, but we have more than one elements inside the first bucket. So what it'll do is it'll compare all the elements that are inside in the first bucket. So to compare, it'll use the equals method for the key. So the first element won't be returning a true for if you're calling the equals method, but the second element would be returning a true. So it'll know that this is the element that we're trying to fetch from the hash map, and it'll return this element. So that is how we can, speed up a searching in if you're using a map, or if you're using a hash map, or a searching can be really fast. Now you might face a question: what is the worst case time complexity for a map? So in the worst case, all the elements would be stored inside. And again, one more thing, when we have two elements or two objects or two keys with the same hash code, that essentially means a hash collision. So our hash map would be the efficiency of our hash map would be reduced when we have hash collisions. So the more the collision, the less efficient our hash map would be, right? And yeah, going back to the question that I was talking about. So if you're asked what is the worst case time complexity of a hash map, so the worst case time complexity of a hash map is n, order of n. Why? Because in the worst case, all the elements would be stored inside a single list, or inside a single bucket, inside the same bucket. And in that case, it'll work as a linked list. It'll just work as a linked list. It won't work as a map. So if you're trying to fetch the last element in the list, you'll have to traverse through all the elements inside the list, all the n elements inside the list, and that would give us the time complexity of order of n, right? And the best case time complexity is obviously order of 1, right? Okay, so the next question is okay, so suppose you are trying to insert okay, so the next question is while iterating over a hash map, suppose you are trying to iterate over a hash map, and at the same time you are trying to insert a value or delete a value. Is that possible? And if it is not possible, what will happen if you're trying to do that? So the answer to this question is it'll throw a concurrent modification exception. So let's try to do that. Let's create a new class, and let's name this test, right? And let's have the main method for this class, and let's say map integer map equals new hash map, right? Okay, and let's do something like map dot root 1 1. Let's copy this and put more elements into the map. So let's say 2, 2, 3, 3, 4, 4, 5, 5, right? Now let's iterate over this map. Try to iterate over this map. So what I'll do is for map dot entry integer I say entry set in map dot entry set. I'll say sysout entry set dot get key and plus entry set dot get value, right? And inside this loop, what I'll try to do is I try to put another value inside this map. So I'll say 6, 6, right? So this doesn't give me a compilation error. And let's try to run this. Okay, so what do we have? Exception in thread main java.util.concurrent modification exception. This is because what we are trying to do is we are trying to iterate over the map, and at the same time we are trying to change the same map. So that is the reason we are getting this concurrent modification exception. This is essentially because hash map is not thread safe. And how do we prevent this, or how do we make this thread safe? So I'll talk about that in some time. So let's look at the next question. So okay, what is a tree map? All right, so you might be asked this question in different ways. So you may be given a scenario where the interviewer may ask or interviewer may tell you that, say you have objects of student, right? And you want to store that inside a map. You want to store objects of student inside a map as so the key should be student and the value should be, say, a department or an object of a department class, right? So what you essentially want to do is you want to sort, or you want to store the student objects in an ascending order based on their age, right? So what kind of data structure should you use? So the answer should be you're supposed to use a tree map, because it stores the key in a sorted manner, right? So let's try to see how a key map or a tree map works. So for that, I'm going to create a class and call it student, right? And inside this, I'm going to say private. Let's have two attributes: private int age and private string name, right? Okay, let's generate constructors. Let's generate the constructor, parameterized constructor, and then let's generate the getters and setters. Select all. Okay, all right. And what else I'll do is I'll generate the toString method as well, right? Okay, Now what I'm going to do is have a main method uh, inside this class, and I'm gonna say map student integer student map equals new tree map, right? I'm gonna do the imports. Now what I'm gonna do is I'm gonna say student map dot put new student. So let's say 24 and name is say ABC, value is 24, right? Let's put some more student objects, or let's put some more entries into the map. Right, so I'll say 18 and the name is AAA, and this is 18, right? Let's say 20 ABC, 20, let's say 24 DEF, 24 AAA, 24, let's say 21 ABC, 21, and let's say 19 DEF, 19, right? So at this point in time we don't have a compilation error, right? Close. At this point in time we don't have a compilation error. We'll just say print student map, right? So we don't have a compilation error now. Now what if we try to run this? Okay, this time we have an error and it says class cast exception, com.demo.student cannot be cast to java.lang.comparable. So when we are trying to store inside a tree map, it essentially expects us to either pass a comparator in its inside its constructor, or this class that we are setting as a key for the tree map must be implementing the comparable interface. So we can resolve this in two ways. So let's say we have a comparator of student type empty, right? Comp equals new ARA comparator. So this should be student, right? Add unimplemented method. Now what you see here is called an anonymous inner class. What does that mean? Comparable is an interface. So we cannot create objects of an interface, right? But what I'm doing is I'm creating a new, using the new operator. I'm calling this comparator comparator constructor, right? So that would essentially create a new object. But this class doesn't have a name. This class, there's no class that implements comparator. So what Java does is it creates an anonymous inner class, and then we can do stuff like this. So inside this, what I'm going to do is we're going to compare the ages. We're going to sort the objects by their ages, right? Integer.compare. So o1 dot get age and o2 dot get age, right? Okay, and we'll pass this comparator inside the constructor for the tree map, right? Now let's try to run this. Okay, so now we have our result, and how does it look? It is sorted by age, right? So first we have 18, then we have 19, 20, 21, and then we have 24, right? What we could have also done is, instead of writing a comparator, let's just remove this, we could have, inside the student class, we could have said implements comparable, right? Type is student, and add unimplemented methods, and inside this we have done is integer dot compare this dot age and o dot get age, right? Now if we run this, get the same result. The objects or the entries are sorted by age. So first we have 18, then we have 19, 20, 21 and 24, right? Okay, so let's move to the next question. What is alright, so we saw what is concurrent modification exception. We are yet to see what is concurrent hash map and how it works. We have seen what is a tree map. Alright, so let's move to our next question. Let's say we have an array list. Instead of a map, we have an array list. So say list of student, right? And say list equals new array list, right? And let's just comment this, and let's comment this as well, right? And alright, I just copy this, and let's have our map the way we had it, and I'll just paste the thing here, and I'll say Control C, V, but I could use all the same student objects that I've created. And yeah, I'll get the imports, and this should be add, okay, Control F, put replace with add list all, right? And just remove this, this, right. So the question here is, suppose you have a list of student objects inside an array list, and you want to sort it based on the student age. How do you do that? So there are various ways we can do it. We can use the collections dot sort, but in that case the list should contain objects of those those type of objects which have the comparable interface implemented. So if we remove this, now our compilation error is gone, and we can run this. We can get the result. Result is same. It is sorted by age. So first 18, then 19, 20, 21, 24, 24, right? Yeah. There's another way we can do this. We could have said list dot sort. So instead of having this implement, right, instead of having this implement comparable, we could have said new comparator. We could have passed a comparator, create an anonymous inner class with a type as student, add unimplemented methods, and inside this return integer dot compare o1 dot get age, o2 dot get age, right? So we could have done this as well. Remove unused imports, save, run this, and we have our result. We have the list sorted based on age. Alright, now there's another requirement. We want to sort the students first based on their name and then based on their age. So that would essentially work like something like, I mean, if we have an SQL statement where we do an order by name comma age. So there are two columns, or there are two fields using which we want to sort our result, right? So how do we do that? So we could have just written the logic for sorting here. So what we could have done is if not equals o1 dot get name dot equals o2 dot get name. So if the names are not same, then we would return o1 dot get name dot compare to o2 dot get name. So if the names are not same, we just sort them by name, and if the names are same, what we would do is we'd compare the ages, right? So what will happen is first they'll be sorted by name, and if the names are same, they'll be sorted by age, right? So let's run this and see how our result looks. So first we have AAA, then ABC, DEF. So we can see our results are sorted by name first, and then for the same names we have the results sorted by age. So first it's 18, then we have 24 for AAA, and then for ABC we have 20 first, 21 next, 24 next, and then again for DEF we have 19 first and 24 first. So this is what we can do. Alright, so let's move to our next question. So okay, so let's go back to this question. What is concurrent hash map? So we have seen that if you're trying to iterate over a hash map and at the same time modify the hash map, such as add a value to the add a key value pair to the hash map, or delete or modify any record inside the hash map, then we'd be getting a concurrent modification exception, and that is essentially because hash map is not thread safe, right? So what we can do is, instead of using a hash map, we can use a concurrent hash map. So we have already seen how a hash map works, right? So for a concurrent hash map, what would happen is, if you are trying to write inside a particular cell or a particular bucket, so that bucket would essentially be locked by map. And if any other thread is trying to, or if there's any other thread, or if there's any other thread that is trying to write inside the same bucket, it will have to wait for the first thread to complete its task or to release the lock, and only then the next thread can write into the same bucket. But the other buckets are free. So if there's another thread that tries to write into another bucket which is not being on which there is no lock, it can do that. So the whole of the map is not locked, rather the buckets that are being written are locked in a concurrent hash map. So that essentially improves the improves the performance of a map in a multi-threaded environment. We could have also used a hash table, but what hash table does is it puts a lock on the whole object of the table, or the whole object. So if you're trying to write into a particular bucket, then the whole object would be locked, and if there's another thread that is trying to write into another bucket, it won't be able to write until the lock is released by the first thread, right? So that is a benefit of concurrent hash map. Okay, so next, what is linked hash map? So linked hash map is basically a hash map which stores stores records in the same insertion order, in which which maintains the insertion order. So if you're trying to insert an object into the map, and then you're trying to insert another object, they're maintained in the same order in which you stored them inside the map. That basically remembers, or that basically carries the address of the next element in the map. So that is how that is what linked hash map is all about, and when to use it. If you want to maintain the insertion order inside your map, then you can use a linked hash map. So that is a brief overview of what kind of questions you can expect in a Java interviews that are related to collections and maps. So I hope you guys like this video, and stay tuned for part 4. Thank you.